we are going to be reviewing solving systems of equations today. So we've talked about these the last couple of years, so we're going to be solving them by graphing and substitution and elimination. So a system of equation, just to review this really fast, is a set of equations. So just like this is a set of equations. Usually we see two. Today we're just going to work with two variables, x and y, and we are looking for the solution. So the pair of x and y values, or maybe there's more than one, maybe there's no pair at all, that make both of these equations true at the same time. So when we're looking at solving by graphing, we have these three different options. So we have an option of there being no solution whatsoever, and that happens when we have two lines that are parallel because there is no x and y value that they have in common. So meaning they never cross each other. This situation is our next option where we have one solution. So one solution is where they cross in one place. There is one intersection. And whatever that point is, that is our solution. That is the set of x and y values that work for both equations and make them both true. We also have this situation where we would have another line, but it's right underneath that one. So they just lay right on top of each other. So they intersect everywhere, which is why we call that infinitely many solutions. So those are our options. So we're going to first solve by graphing. So just a reminder of graphing, we like our equations to be in this form, in the y-intercept form, so that they're solved for y. Sometimes you might have to set it equal to y or get y by itself. But then when I have it in this form, this b over here tells us where our y-intercept is, and that's the number one thing that we look for when we graph. And then from there, we use the m, which is the slope. So this is the number 2 part that we use, and that usually gives us our rise over run for the slope. Sorry. Maybe I should put that in the right place. So here we go. So our first equation over here is y equals negative 7x minus 1. So I'm going to start with my y-intercept. So it's always the number that's hanging out by itself, no variable. So that goes right on the y-axis, negative 1. And then from there, number 2 is this number in front of the x. And then for us, that means our slope is negative 7. So a lot of people, since we think of it as rise over run when we're on a graph, like to put that in a fraction form. So we can always put any number over 1. So negative 7 over 1. And just to review, when we're looking at a negative slope, this is about slope here. When we're looking at a negative slope, from left to right, it has to be going in a down direction. And then for a positive slope, from left to right, it goes in an upwards direction. Now this might be confusing because you will see arrows on both ends of your line, but it is the right side that tells us what the slope is. Always left to right is how we look for positive and negative slope. So we are going to go negative 7 over 1. It doesn't matter if I go up or down from here. So let's go 1, 2, 3, 4, 5, 6, 7. And then this time I have to move to the right one because remember from left to right, I want it to be moving in a negative direction since we have a negative slope. If I go up 1, 2, 3, 4, 5, 6, 7, then I have to go to the left one so that when I connect all of these, it's going downwards from left to right for the whole time. Now I'm going to switch to my second equation. So first, again, we look at our b, the number by itself, no variable. That's where we start at negative 9. So that goes right on our y-axis. Positive 1 is our slope. And again, we can always put that over 1. So positive is going up from left to right. So up 1 over 1, up 1 over 1. We can just do that over and over and over. And you can go down 1 to the left 1, but just so we make sure that we are going in an upwards direction from left to right. Now, I usually like to keep my dots going and do this all the way across the graph. However, what we're trying to do is to solve this system of equations. So if I can just see where it's intersecting already, then I'm good to go. So I just have to now identify what is my solution. So that point right there where they intersect, I just have to write that point down. So my x value, if you line that up with the x-axis, looks like it's at +1. Line that point up with the y-axis, -8, and there's my solution. So if you want to pause this video and try this one yourself, go for it. I'm going to first start, again, just like I did before. These are already solved for y, so start with my y-intercept at +2. I have a positive slope of 5/2. So up 5, again, it doesn't matter if you go up or down, but it has to be a positive slope in the end. So 1, 2, 3, 4, 5/2, so there's my dot there. Then I can go down 5, 1, 2, 3, 4, 5, to the left 2, so it's still a positive slope from left to right. 5/2, connect those. Oh. And then let's do our second equation. So +4 is where we start with our y-intercept. So right there at +4, slope is the same, 1, 2, 3, 4, 5/2. And then we can go the other direction and connect that line. Now, if you remember working with a bunch of linear equations last year and the year before, anytime you have two lines that have the same slope, that means they are going to be parallel to each other. And if they start at different places, then obviously they're going to be parallel and not right on top of each other. So this is a case where we'd have no solution because they never cross. So now we're going to find these same answers, same type of answers, solving in a different way. So solving by substitution, if you want to write this down, you can pause the video. Our goal for substitution is first that we want to get one of our variables. I don't care if it's x or y. We want to get y alone or x alone. We want to get it isolated. Because when it's alone, we can see now that y equals all of this. So anytime I see a y, like right here, I can replace it with all of that stuff that I circled. So what we're going to do is we're going to take this other equation, 7x, the second equation, +3, and then instead of y, I'm going to take y completely out, so you erase the y, and then I'm going to replace it with what y is equal to, all of this stuff that I circled, -5x +30, and then continue my equation. So now I have substituted this y in the second equation for what y is equal to, and now I have an equation with one variable, so I just need to go about solving this. So we distribute the 3 to both of those terms right there. We can combine like terms, so we have two like terms right there. Oops. And then we need to get x by itself. So let's continue. So -90 on both sides. We have -8x equals -50. Oh, I changed that to a 40 somehow. 42. Let's try that. So here we go. Now this is going to be -48. Divide by -8. Divide by -8. X equals 6. Okay, so we have half of our answer, but remember back on the graphing ones, the only time we can have an answer is if it's a point. And a point has to be in the form of x, comma, y, and I only have half of that. I only have my x. So after we have that x value, we are going to take it and substitute it back into one of these original equations. I'm going to do it into the first one. You can do it into the either, but I will do the first. So x equals 6. So I'm going to rewrite this first equation, y equals -5, but instead of x, I'm going to take out that x right there and replace it with what x is equal to, or plug in our value for x, which is 6, +30. And then we simplify, so -30 + 30, so y equals 0. And don't get this confused with no solution. A lot of times when people get to y equals 0, they think, oh, it's no solution, but 0 is a solution. So then my solution would be x, my x value, which is 6, my y value, which is 0. And if we graphed that, we would hopefully see that they cross at 6, 0. So that was a one solution. Okay, substitution again. Go ahead and pause the video and try this out. But remember, first, we need to make sure that one of our variables is isolated. So this time I'm going to I have to do a little work to isolate the x, and it's easiest if you can find a variable that has no other coefficient, leading coefficient in front of it. So x by itself, so I need to add 7y to both sides, plus 7y. I'm going to rewrite this out to the side, so that will go to 0. So then here I have x equals 53 plus 7y. And now I have my x isolated. So x is equal to all of this stuff. So anytime you see an x, like right here in this second equation, I can replace it with all of this stuff in the circle of what x is equal to. So that's what I'm going to do. So I'm going to take this second equation now, -4, but instead of this x, I replace it with everything that x is equal to. 53 plus 7y. And then continue finishing the equation. And now I have an equation to solve. So this is the stuff I replaced x with. So go ahead and distribute. -4 times 53. So we have -212. 7 times 4, 28. We still have our -5y equals 19. So I can combine these two like terms, but at the same time, I'm going to be moving this over so I can combine it with its like term on the other side. So combining those, I get -33y equals 231. And hopefully this is going to be divisible. And it is. Perfect. So negative divide by -33. I mean, sometimes we get decimals, but it's really nice when we don't. So when I divide that by -33, I ended up getting -7. So there's half my answer. Remember, we have to have an x value and a y value. So I'm going to take this and I'm going to plug it. Actually, I'm going to use this one right here that I rearranged. So then I have x equals 53 plus 7. Instead of 7y, I'm going to do 7 times -7 because now I know what my y value is. And we simplify. 7 times 7, -49. So x equals 4. There's the other half of your answer, but don't forget, your final solution needs to be written either no solution, infinitely many solutions, or as an ordered pair. So my x value goes first, y value goes second. So there is my final answer. Let's check to see if that's right. And it is. Perfect. So last strategy for solving is elimination. So our strategy for this one is different. We do not want to isolate yet, but we want to make it so that we have either in our x's or our y's, so we're looking here or here, we want to have a positive and a negative version of the same number. So this is actually already nicely set up for our elimination because if you notice on our y values, we have a +2 and we have a -2. So we are already ready to eliminate on this one. So when that's the case, all you do is you draw a line underneath and you add your equations together. So then 3x plus 5x is 8x. 2y minus 2 plus -2y goes to 0, so I don't have to write anything at all. And then I write this, 64, add that all together. And now look, I have this equation, so nice looking equation down here that I can just solve. Divide by 8 on both sides, x equals 8. So there's half your answer right there. And same way as before, I'm going to take that and plug that back up into one of these equations up here. I'll just use the first equation. So instead of 3x, it's going to be 3 times 8, because now I know what x equals. Plus 2y equals 22. And then we solve. 8 times 3 is 24. subtract to combine your like terms, and divide to get y by itself. So there we go. We have our two answers, or our two numbers, and we write our one answer with our x first and our y second, and that is our solution. Now the next one we're going to try is still by elimination, and this is our last example, but it's not set up for elimination yet. Remember, our goal for elimination is to get a positive and negative of the same number. So since I don't have that yet, what I can do is, since I have an equation, remember with equations you can do anything that you want as long as you do it to both sides of the equation, as long as it stays balanced. So I'm going to take this equation right here, and I'm going to multiply the whole thing times -3. Can you see why I would want to do that? My goal is so I can get a positive 3x up here and a negative 3x down here. That is my goal. And you can focus on the y's if you want to get the y's together. And sometimes you can multiply both equations. But in this case, I only have to multiply one, so I'll just stick with that one. So my top equation is the same, -21, and then I'm going to multiply that whole bottom equation by -3. So -30y. Even this number on this side is going to be multiplied by -3. So -63. And now that I have that, I'm ready to add my equations together. So the x's go to 0, so I don't even have to write any of that down underneath. And then I have 2y plus -30y. -28y, and then I add these two together and I get -84. Divide by 28, -28, divide by -28, y equals 3. So there's half my answer. So it took a little bit longer to get to the y, but not bad. And then I need my other half, so I take this, let's plug it into this one. That was a long way to get there. That's okay. Okay, so I have x plus 10. Instead of 10 times y, I'm going to do 10 times 3 equals 21. So x plus 30 equals 21. Solving for x, so I minus 30 on both sides. I end up with -9. There's the other half. So final answer, I write my x value first and then my y value, and that would be my final answer. Let's check on that one, -9, 3. Okay.